I need to get new batteries in this thing. All right, so trig identities, fun stuff. Objective is to simplify trig expressions using identities. All right, we wait all the way to the end of the year to do this stuff because it'll blow your mind. All right, so when I take a look at example 1, I noticed something. What do you know about tangent? Take a look at your chart. What do you know about tangent? Sine over cosine. Do you see how that would help us simplify it? I mean, you could probably get the answer now, can't you? So my hint to you is, if you can, one of the hints is try and change everything to sines and cosines, because those are our basic building blocks. So I agree, tangent. See, this is how I'm going to use my unit circle identity sheet. There's tangent, right? This is how I use it. Tangent is sine over cosine. So I'm going to use, instead of tangent, we're going to write sine theta over cosine theta times cosine theta, right? He's here. All right, you want to finish your test? Alex, here you go. Why don't you sit way over there? Okay, thank you. So then, it's easy. That's really like cosine over 1, agreed. Cosines cancel. And this expression, tangent cosine, can actually be written as sine of theta. Much simpler version, correct? Okay, all right, this is what we're going to do. So example 2 is going to take a little bit of multiplying. So let's try and simplify it first. There is no 1 minus sine, but there is a 1 minus sine squared, right? So I can't really use anything yet, but I'm just going to multiply. I go that times that. So 1. 1 times a sine of A is a positive 1. Sine of A. Negative sine of A times 1 is a negative 1. Sine of A. And then sine times sine, I get a negative sine squared of A. Okay? That's easy. And of course, I'm sure you see what happens next. Cancel the signs, right? Do we agree? Cancel the signs, cancel the signs, cancel, cancel. And now we're left with 1 minus a sine squared. So here's my hint. When you have any trig squared, use your Pythagorean identity. So use your Pythagorean identities. Because I believe we have a 1 minus sine squared. It's right there. Which makes this thing equal to a cosine squared, right? So instead of 1 minus sine squared of A, we're going to go call it a cosine squared of A. What do you think? Do you like these or you hate these? I like these too, Lauren. I like these a lot. But remember, I have a sick mind. Okay, now, example 3. So, when I look at it, what could be something we could do? Let's move tangent. I agree, tangent. Let's move tangent into a sine of x over a cosine of x times this sine of x, right? What else can we do? Is there anything else we can do? Change the secant into a 1 over cosine of x, right? Well, it doesn't look any better, does it? But I have 1 minus cosine, subtract a sine squared. You okay with that? So I really have a 1 over a cosine of x minus a sine squared of x over a cosine of x. Yeah, because they've got common denominator. You guys agree with that? Common denominator, so let's put them together. So my common denominator is cosine of x. And then in the numerator, I have a 1 minus a sine squared of x. And I think I already did this. Haven't I already done the 1 minus sine squared? I think I did that identity, right? I sure will, Ellie. Sorry about that. You have to forgive me. I have fun doing these. So you guys say, Mr. Davies, slow down, okay?
Slow down.
Slow down. Chill, Bill. Just say chill, Bill, okay?
Chill.
Chill, Bill. I would never say this in any other class except for this one.
Isn't that a song?
You guys are the best. There's no doubt about it. You guys are the best. So now, we have that identity, 1 minus sine squared somewhere. What is it? You guys see it?
Cosine.
It's cosine squared, right? I think if I look at my sheet, it's a squared. 1 minus sine squared is a cosine squared, so I'm going to rewrite this as a cosine squared theta over a cosine theta. Now, just as a little side note, if you had x squared over x, you'd cancel an x, wouldn't you? Right? You cancel. So you do the same thing. Cosine squared over cosine, we'll cancel a cosine with a cosine, and we'll be left with just a cosine of theta. Or actually, it's x. I lost my x, didn't I? I always tend to do that. What do you think? So this ugly mess simplified all the way down to just cosine. You see how why we want to do this? It really makes them easy, okay? Ready to turn the page? Okay, all right. Now, example 4. I think I've seen this somewhere. Cotangent 90 minus theta. Cotangent 90 minus theta. It's right here. 90 cotangent 90, it equals what? So let's rewrite this expression, cotangent 90 minus theta, into just tangent of theta, okay? All right. Now, what do you think we should do? Change the tangent into a sine over cosine, right? You guys agree with that? So my tangent is equal to sine over cosine. Hopefully you can see how that's going to help. Sine over cosine will be able to cancel the cosines, but I'm getting ahead of you, right? Let's change this into a sine theta over a cosine theta. And then it gets easy, right? Cancel the cosines, and it becomes just sine of theta. All right. Example 5. Example 5 is a little bit harder. There's lots of ways to do example 5. What do you think? Give me a stab at it. What do you think? What do you think? Anybody? Here? Okay, I will tell you this. When I was your age and I did these, for some reason, I always did them the hard way. Always. I never saw the easy way, and I always got them right. But I would take 10 steps when some smart kid sitting next to me would get it down to 3 steps. It's okay. I now see the easy way, so I'm going to pass that on to you, okay? Lauren, what do you think? So let's change the tangent. I think changing the tangent's not a bad idea. Okay, so what do we know about tangent? Yeah, so I'm going to rewrite this as sine squared of a over sine squared of a over cosine squared of a. Okay, all right, good. Okay. I'm going to take this and I'm going to divide. When I divide, I invert and multiply, and then the sine squared will cancel, but I'm going to show you, okay? I'm going to invert and multiply, because divide, and the sines will cancel. But I want to show you that, okay? I'm going to do it step by step, okay, so you see. So, let's go sine squared of a over 1 times, flip it, right? Because when I divide, I invert and multiply, cosine squared of a over sine squared of a, okay? Now what I did was this. Fraction divided by fraction. When you divide fractions, I multiply, right? And then you can cancel your signs, right? Sine squareds cancel. And I'm left with 1 minus cosine squared of a. Now that's, I think that's somewhere too, right? If I look at my identity, it is sine squared. 1 minus cosine squared is right there. It's equal to a sine squared, so I'm going to rewrite this as a sine squared of a, which is a much simpler version than our original. It took a while to get there though, right? Okay, so here's what I have. Page 321, 1 through 6 all. Some of these are A, B, and C, but the first ones are pretty easy. I'm also going to leave my answer book up here so you can check, okay? The only way you can get good at this is to practice it.